Okay, I hope you have gone through the statement, and let's read this statement together. This is given in your book. Calculate change in entropy when 1 mole of saturated ethanol. Remember, what kind of material is this? Saturated ethanol. Vapor condenses at its normal boiling point. Normal boiling point, and condensation happens, right? So let me draw this picture for you guys so that you can understand this process much better. Let's say we have a process, a closed process, a closed system. That's why we have closed system. What we have got 1 mole of saturated ethanol, saturated vapor. All of this is what? Vapor, no liquid, right? Saturated ethanol, right? Vapor. What does it mean? That it is saturated, just like saturated vapor, not superheated steam, not saturated liquid. It's a, remember, if I draw this was saturated liquid, this was saturated vapor, and this was superheated steam, right? So all of this is got vapor, right? Now we need to calculate entropy change when 1 mole of saturated ethanol condenses from vapor phase to liquid phase, and temperature is at its normal boiling point, right? Do you remember formula? Delta S is equal to Q over T, right? So that's why the author has mentioned what is the temperature. Temperature is normal boiling point, and which makes sense because vapor becomes liquid at normal boiling point. Just like if we have saturated water vapor at 100 degrees Celsius, at what temperature that will become liquid? 100 degrees Celsius, which is a normal boiling point, right? Similarly, saturated ethanol vapor will become liquid at normal boiling point, right? So this is the process, and we need to calculate how much entropy will be done, or entropy will be generated in this process, right? When this vapor will become liquid. Now to calculate this, as you can see the formula, we need two informations: how much heat is transferred and how much is temperature, right? Because this is a phase change happening, what should be this thing? This should be heat of vaporization, or enthalpy of vaporization. What does it mean? If we have a liquid, no vapor, how much energy we need to make this vapor? What is that called? That is called enthalpy of vaporization. Let's say that is 10 kilojoule. Now if we have vapor here, after some time, how much energy we need to remove to make it liquid? That would be minus 10 kilojoule, because I think in this case we were giving energy, and after it became vapor, to make it back to liquid we need to remove this much energy, right? So the enthalpy of vaporization is the amount of energy that is required to make liquid to vapor. But in this case we are condensing, so that logically it makes sense that how much energy we need to remove from the process to make it liquid back, right? So that's why it's given that enthalpy of vaporization is here. Enthalpy of vaporization for vapor ethanol is this much amount, which is 38.56. And at what temperature that process happens, that's a boiling point or normal boiling point, and that is given 78.2 degrees Celsius. These information must be given to you if this question comes in exam. So this much amount of energy is required to give to the liquid to make it vapor. So that means same amount of energy we need to remove from the vapor to make it liquid. And this is the temperature at which this phase change happens. And remember, either you move from liquid to vapor, from saturated liquid to saturated vapor, temperature is same. Or if you move from saturated vapor to saturated liquid, the temperature is still the same. So that's why the energy of vaporization, that is amount of energy to make liquid vapor, the same amount of energy need to remove, but with negative sign or opposite sign. That's why it's negative sign here. So that's energy which is delta Q or delta H, that is Q, and this is temperature or normal boiling point, which is 78.2, and if you convert that into Kelvin, so this becomes this. So now you can see this is the entropy. Remember, these are the units of entropy, right? Why it's negative sign? Negative sign mean entropy is increasing or decreasing. So this is very important, because vapor is less ordered form, liquid is more ordered form. You are moving from less ordered form to more ordered form, mean you are decreasing entropy. Negative mean entropy is decreasing, right? The entropy change for the system has a negative value since the liquid is more ordered state than the vapor. However, the process do not violate the second law, since it is entropy change of the universe must be greater than 0. So that means entropy of the system is decreasing, but at the same time entropy of the surrounding is increasing, because negative sign mean this energy is going from the system to the surrounding, and that is causing increase in entropy. So mean if you will combine them together, both of them, entropy of the universe should be positive, entropy of the system should decrease, entropy of the surrounding will increase. I hope this question is clear to you guys.